Hello everybody, and welcome to this video where we're going to look at elastic collisions more in depth. So a quick reminder, we've seen before that elastic collisions are objects colliding and then bouncing off of each other. So this is a bit different from inelastic collisions, where in inelastic collisions, as we've seen from before, the two objects kind of form a larger mass, and that larger mass either is going to be static after the collision or it's going to move in a certain direction. So here in elastic collisions, the two objects remain after the collision and they end up moving differently. So what does this mean for the formulas? So because this is what we're interested in at the end of the day, what does this mean about the formula? So the formula definitely becomes different. So this was the formula for inelastic collisions. So now there must be something that's going to happen to it. So first, let's look at the momentum before the collision. So we have the momentum for object A, and it's going to be equal to ma va. We have the momentum for object B, which is mb vb. So that means the sum of the momenta before the collision is equal to ma va plus mb vb. Awesome. Nothing special. Let's look at what happens after. The momentum after. Now, because I want to separate between the symbol for the momentum before and the symbol for the momentum after, I don't want to just call the momentum PA when it's after the collision, because I want to make sure that I'm separating it from the momentum before the collision. I want to make sure that these two symbols look different. So to do so, we're going to add this little symbol over here. This is called the prime symbol, and we're just going to use it to mean that this is the momentum after the collision. So this doesn't affect our calculations. It's just another symbol that allows us to differentiate it from the momentum of A before the collision. So knowing this, PA after the collision is equal to the mass of A multiplied by the velocity of A, but again, the velocity of A now is also different. It's not the velocity A as we have seen before. These two are not the same. So again, because we are talking about after the collision, we're going to use the same symbol for VA. So we're going to add this little symbol over here. Now you might ask me, why don't we put M prime A as well? And the answer for that is, well, because this is the same mass. Why would I? Right? Why would I add a prime symbol if the mass is still the same? So we're going to keep MA as it is because it is the same from the beginning all the way to the end. The mass does not change, but the velocity definitely ends up changing, right? So first we were going this way, now we're going the other way. So definitely V prime A is different than VA. Knowing this, we can set up the momentum of B after the collision is going to be the same thing, MB V prime B. So now when we want to put P after, the momentum after the collision, it's going to be MA V prime A plus MB V prime B. Now if we want to be a little bit more clever, we can remove the before here and say this is just P. And we can remove the after here and say this is P prime. Right, we can definitely do that. And I'm going to keep it like that, in fact. So now that we have the momentum before and the momentum after, we know the very, very important fact, and that is momentum is conserved. And what this means is that P is equal to P prime. The momentum before the collision is equal to the momentum after the collision. So now we can expand these, right? We can say that momentum is this, and we plug it in here, and the momentum after the collision is this, and we plug it over here. So we're gonna do exactly that. So I'm gonna copy these two. This is the momentum before the collision, and this is the momentum after the collision. And these two are equal to one another. And this, in fact, will end up being the formula for elastic collisions, specifically for perfectly elastic collisions. But this is the only case we're going to take.